Number 1. To prove by mathematical induction that 1 squared plus 2 squared plus 3 squared up to n squared equals n over 6 outside of n plus 1 times 2n plus 1, is assume that 1 squared plus 2 squared up to k squared equals k on 6 into k plus 1 times 2k plus 1, just replacing the n with k. And instead is required to show that k on 6 times k plus 1 plus 2k plus 1 plus k plus 1 all squared equals a, b, c, or d. Now for n equals k plus 1, so for n equals k plus 1, we have 1 squared plus 2 squared plus 3 squared plus up to k squared plus k plus 1 all squared is equal to, now just replace the n with k plus 1, so it'll be k plus 1 on 6, this becomes k plus 2, and of course this one becomes 2k plus 3. Fact is this side here. Now 1 squared plus 2 squared plus 3 squared plus k squared we know is equal to this, so we can say that k on 6 into k plus 1 times 2k plus 1, which is all of this, plus k plus 1 all squared equals this, which of course is what we're required to prove. But we should actually go ahead and see if that is the case, that that does equal that. So I'll take out k plus 1 as a common factor. We've arrived, D is the correct answer. We'll take k plus 1 outside and we'll have a k of 6. This is what you have to do with formal induction proofs. That's k plus 1. That's what that equals. And that becomes k plus 1 becomes 2k squared plus k plus 6k plus 6 on 6, and of course this becomes k plus 1 on 6 times 2k squared plus 7k plus 6. And of course when you factorize that, you do in fact get this side here. That's your k plus 2 and 2k plus 3. Again, which is D.